All right, so finishing up Newton's third law. So there's three laws. His first law was inertia. The second law was Fu ma. Third law. What is Newton's third law? States that for every action, there is an equal and opposite reaction. All right. So if you punch the wall as hard as you can, the wall punches your fist back as hard as it can, and that's why your fist hurts when you punch a wall, because the wall punched back. All right, that's simple. So the example I have here is a cart has a chamber inside where there's a spring. So I need a bit of a picture here to help visualize this. So inside this cart, we've got a coiled spring, and here is my marble. All right. It launches the ball horizontally, so there's my diagram. Cart's 1.2, so mass of cart is 1.2 kilograms. The mass of the ball is 0.07 kilograms. The spring exerts 2 newtons of force on the ball, and it's going to be, all right, identify 3 action-reaction pairs of forces here. Okay, so what that means is that what happens when if this is on wheels, this contraption, and we fire the ball's obviously going to go to the right. What's going to happen to the cart? Well, the cart is going to move in the opposite direction because there's nothing holding it back. So our action-reaction forces, so spring on ball, and the reaction force to that would be the ball pushing on the spring. Remember that ball, Newton's first law says that ball is stationary. It's quite happy the way it is. The spring then tries to push the ball out the chamber, so the ball reacts by pushing back the same force. What happens then? Why does the cart go backwards? Well, spring on cart then. Because the ball is pushed back on the spring is now going to push back on the cart. The cart then is pushing on spring, and that's what allows that ball to actually exit the chamber. The third one then, let's go cart on ground. There'll be a bit of a friction between the wheels and the ground, so the ground on the cart. All right, so those are action-reaction forces. Okay, one pushes, the other one's going to push back. So B, draw a free body diagram of the ball and calculate its acceleration while the spring is pushing on it. So here's the ball inside the chamber. And there's your force due to spring. Because it's in the chamber, I'm going to say that there's the force due to gravity acting on it. It's sitting inside the chamber. The chamber is holding it up, force normal. And because the ball is going to accelerate or move out, it's unbalanced, so there's nothing opposing it. I guess we're assuming there's no friction inside the chamber. So Fu ma is what we're looking at. Unbalanced force. We know the spring is pushing with 2 newtons of force. We know the mass of the ball is 0.07 times acceleration. And 0.07, divide that on both sides. So that ball will exit the chamber at, what's that? 2 divided by 0.07, 28.6 meters per second squared to the right. Therefore, it exits with 28.6 meters per second squared. So, right, so that's the acceleration of the ball outside of this chamber. Okay? What do I got left here? So one thing I want to talk about then, I'm going to add a C part then on this one because it's kind of interesting then. The cart. Okay? We said the cart's going to move backwards because when the ball exits, the cart slides backwards. So what happens to the cart? So the cart has the force due to the spring acting on it. It's got force due to gravity and normal force. So what happens with it? Fu ma. 2 newtons of force. The spring is also kicking off of the cart, so it's acting on that cart. The cart's mass was 1.2, so we can find its acceleration. And we'll find its acceleration's much less because it's much more massive than the ball itself. So it's 1.7 meters per second squared, and that's to the left. Okay, so the cart is going to go backwards, and if you compare the two accelerations, and that's due to the difference in mass. So it's like kickback. So when you fire a rifle, the bullet exits with an acceleration, a high acceleration, but there's kickback from the rifle, and that's why you've got it up against your shoulder. That's what you're feeling, is that Newton's third law. So some real life applications here. A simple one is tires. Newton's third law is the only reason that we're actually able to drive. Okay, so our motor transfers force to the transmission, drive shaft, etc., etc. And I'm gonna make some nice white balls. Look at that, classic tire. So the tire is gonna rotate in that direction. So why is this tire, or why are we allowed to go forward or move forward? So it's applying a force at the point of contact, and it's in that direction. All right. So why are we able to go? If my tires are rotating clockwise, that means I'm heading in that direction, but the force is applied backwards. So what allows me to actually move forward? It is that force due to friction that allows us to move forward. If we didn't have friction at the point of contact, your tire would just spin. It wouldn't be able to move forward. That force due to friction allows the tire to move forward, excuse me, and allows us to drive. Okay? Another one's jet engines. So here's how a jet engine works. In general, it's not a terribly precise schematic here. So we have cold air collected. So cold air comes in the front of the jet engine. It's collected. It travels, and what we have is fuel entering the chamber, and it gets ignited, which means that there is heat generated in here. So that cool air that gets compressed into this chamber or rammed into this chamber gets heated and drives out the back. Okay? So that's hot air exiting. We know that hot air expands, so it will exit quicker. Due to a pressure buildup. All right. But why does the plane move? Or why does the engine push the plane? This air that's exiting is pushing against air particles. So right there we have Newton's third law. All right. The hot air pushes against against the air particles behind the engine. If we were in space and there was no air particles, jet engines don't work. All right, the jet engine has nothing, Newton's third law won't work because there's nothing up there for the jet engine to push against. So the jet engine simply works on this air being expelled very quickly and pushing against the air that's on the outside of the chamber. Okay. In the homework, there's a bunch of other Newton's third law questions that you're going to go through and say, oh yeah, that makes sense. So if you have any questions, let me know, and I'll clean them up or give you a hand, and good luck with homework.